In this vodcast, we're going to take a look at empirical formulas. In the next vodcast, we'll look at molecular formulas and their relationship together, but this one is specifically empirical formulas. The thing that you want to remember about empirical formulas is that we're talking about the lowest whole number ratio of elements in a formula. We're not talking about the actual formula of the compound, it's the lowest whole number ratio, and that's important. The word empirical comes from laboratory data, so basically what we're doing is figuring out the formula based on lab data. Well, the first thing we want to do is talk about what an empirical formula is by giving some examples. So if you look at these following examples, the question would be which one of these are or which one is an empirical formula. So you're looking for the lowest whole number ratio. So for example, C2H4 is not the lowest whole number ratio. That could be reduced to H2. So CH2 would be the empirical formula of C2H4. C2H5, on the other hand, is an empirical formula. You can't reduce that to a lower whole number ratio. C3H9 we could reduce to CH3. It's a 1:3 ratio. CN2H4. The classic mistake here is to see the 2 and the 4 and think, oh, well, those can be reduced to 1:2. But you've got to remember, you've got the carbon here with a subscript of 1, so that is an empirical formula. You can't reduce it any further because you'd have to reduce the carbon also. The same thing goes for the C2OH4. The 2 and the 4 are reducible. However, you've got a subscript of 1 for the oxygen, so you can't reduce that formula any further. C4H9 falls into the same category. You can't reduce that to a lower whole number ratio. You could reduce that, you can't divide both of them by 2. Alright, so now that we understand that the empirical formula is the lowest whole number ratio, what we want to do is go through the steps of determining how to solve for an empirical formula. And it really is a basic 4-step process. First of all, you want to make sure all of your units are in grams, unless, of course, you are instructed otherwise. Once we're in grams, we do what we do. We're going to convert to moles, and we're going to do that by using the molar mass on the periodic table. My pen has a little bit of a delay today, apparently. After we convert to moles, we want to divide by the lowest of the values to determine the ratio. In other words, what's the lowest whole number ratio? And then the last step is, if it's not a whole number ratio, we're going to multiply by the lowest factor. So as we're doing these problems, you might want to refer back to this slide or back to this part of the video and look at the rules as you're doing the problems. So let's take a look at a few of these problems. Let's start with this one. It says determine the empirical formula of a compound that is made up of 72.4% iron and 27.6% oxygen. What you want to do is assume that this compound that we're trying to find the formula is a 100-gram compound. So we're trying to find the formula for iron something, oxygen something. So if we assume we have a 100-gram sample, that would mean we have 72.4 grams of iron and 27.6 grams of oxygen. Let's convert to moles. So go 56 grams per mole. Molar mass off the periodic table for iron. Let's do the math. 72.4 divided by 56 gives us 1.29. Yes, my pen is acting funny. We're going to convert this to moles. 16 grams of oxygen per mole. And again, we're finding formulas, so we're not going to use the diatomic form. We're simply using the singular form or elemental form. So 27.6 divided by 16 gives us 1.725. Okay, so now to make this a lowest whole number ratio, we're going to divide each of these by the smaller of the two. So we're going to divide them each by 1.29, and we get 1.29. So 1.725 divided by 1.29 is going to give us 1.3. Or we could say 1.33. Now step 4 says at this point, if this is not a whole number ratio, we have to multiply each of these by a common factor to make those a whole number ratio. What you want to do is start with 2, see if that works. If that doesn't, move to 3, then 4, etc. So if we were to multiply these both by 2, we would get 2 there, and then 2.66 there. Well, 2.66 is not a whole number, so if we multiply by 3, we would get 3, and we would get 3.99, which we can round to 4. Remember, if our decimal is 0.9 or above, we can round to 1, or if it's 0.1 or below, we can round it to 0. So our empirical formula here is going to be Fe3O4. Let's take a look at another problem. Okay, so now we're going to find a compound that is 65.2, and I'm going to write my percentages in grams of scandium, and 34.8 grams of oxygen. Okay, so now I'm going to do the next step. I'm going to convert these to moles. I think I lost my pen. Actually, alright, there we go. So I'm going to convert these to moles. The molar mass of scandium is 45, so I can say 45 grams per mole. Oxygen, again, 16 grams per mole. Let's do the math. 65.2 divided by 45 gives us 1.45. And down here, 34.8 divided by 16 will give us 2.175. So pick the smaller of the two, which is 1.45. Divide each of them by that value. We'll get 2.175 divided by 1.45 will give us 1.5. So 1 to 1.5 is not a whole number ratio, so again, start multiplying by a factor, and I think it's pretty obvious that you can see 2 is going to work. So 1 times 2 is 2, 1.5 times 2 is 3. So our formula is going to be SC2O3, and that's going to be the empirical formula of our compound. Okay, let's take a look at one more problem. Determine the empirical formula that is 70% iron. So again, I'm going to write my percentages as grams, and 30% oxygen. And again, write your percentages as grams. Let's convert to moles. 56 grams per mole, again, off the periodic table. Oxygen's molar mass, 16 grams per mole. Let's do the math. 70 divided by 56 gives us 1.25. And 30 divided by 16 gives us 1.875. I'm going to divide them both by the smaller of the two, 1.25, divided by 1.25. I'll get 1.875 divided by 1.25 is going to give me 1.5. So again, I'm going to multiply by the smallest factor, each of them, to get 2 and 3. So our formula is Fe3O4 2O3. Okay, let's just do one last problem. If we have our values in grams, then we don't need to start with percentages. We would simply start with grams. 2.61 grams of carbon, 0.65 grams of hydrogen, again, not the diatomic form, simply hydrogen, the singular form, and 1.74 grams of oxygen. So now we've got a compound with 3 elements, and it's the same process. We'll go 12 grams per mole, because we're going to convert these to moles. Hydrogen is 1 gram per mole, and oxygen is 16 grams per mole. Let's do the math. 2.61 divided by 12 gives us 0.2175. And notice I'm not rounding here. That gives us 0.65, and that's going to give us 0.109. Pick the smaller of the 3, which is 0.109, and we're going to divide all of them by 0.109. And let's do the math. 0.2175 divided by 0.109 gives us 1.99, which we can round to 2. 0.65 divided by 0.109 gives us 5.96, which we can round to 6, and that's going to give us 1. So our empirical formula is C2H6O. Okay, see if you can do this problem on your own. You're going to take your percentages, you're going to write them as grams, you're going to convert to moles, and then find the lowest whole number mole ratio. In the next podcast, what we'll do is take a look at molecular formulas. But just remember, empirical formulas are the lowest whole number ratio of elements in a compound. So if you can reduce the formula to a lower whole number ratio, it's not an empirical formula. If you can't reduce it, it is. So we would have, just to look back at our slide here, that would be the empirical formula, not that. Empirical, empirical, and the 3 on the bottom here are empirical. Okay, good luck with that last problem.